Hi everyone, welcome to Meridas.com. Today we are going to conduct our demo lecture number 1 where we will be discussing that what sort of features and what sort of advantages we have in our checkpoint firewall. So this demo lecture is for the course which we are going to start, which is checkpoint CCSA and CCSE. It's an integrated course we are launching on Meridesk.com. So without further delay, let's jump in. Okay. So, the first thing you'll get in this particular course is 35 plus hours of live classes and from which 20 plus hours will be your lab. Okay. So our approach will be first will be discussing the theory part and simultaneously will be discussing the lab part where will be performing lab for each and every topic we will be discussing in our course. Like I have multiple life scenarios which I'll be discussing in this particular course. For an example, uh, when we'll discuss the VPN section, right? There we'll discuss if let's suppose somebody wants to make policy-based VPN or route-based VPN. What are the difference? What are the features you will get in route-based? What are the features you'll get in policy-based? This is how we'll be proceeding in our course. Apart from this, we have a very important feature in with Meridesk, which is interview preparation guide. Okay, what is this? Basically, after this course, I'll be sharing you one or two PDFs in which you'll be having some scenario-based questions, some PDFs I'll be sharing where interview questions will be listed. What you have to do, you have to complete the course, you have to, finish your revision, and then you have to open these PDFs from where you have to evaluate yourself where you stand. If you are able to answer at least 90% of the questions from the PDF, that means you are good to go for any of the interview. Okay, I'll not say that all the interviewers will ask the questions from this particular PDF, but believe me, approximately 85 to 90% of the questions will be from this particular PDF. Or you can say the reference will be from this particular PDF, not the exact questions, but the topic will be asked from the PDF. That's my experience. That's the feedback I have received from the students to whom I have sent this particular guide or I have shared this particular interview preparation tips. Okay, important interview questions topic wise, which we'll be discussing in our classes. Like if let's suppose we have completed our cluster Excel class, maybe high availability class, right? So after that class, my approach is I always used to give some questions topic wise. For example, if I talk about the cluster Excel, so what is the protocol Checkpoint uses in clustering? Right? This is a very important question if you go for level 2 engineer, right? So that protocol name is CCP, Checkpoint Control Protocol. That's the protocol through which the clustering forms in Checkpoint. All right. So these questions I'll be telling you after each and every topic. If you talk about this particular lecture, I have some questions over here also. Can you see this? These are the lecture 1 questions. Why we should prefer Checkpoint? What is the SMART? This is the acronym, right? If you have seen my previous video, I have discussed this SMART architecture. What is SMS? SMS I'll be discussing today, right? What is 3-tier architecture? This we have discussed in previous class, right? What is the packet flow of Checkpoint? See, generally, like in my classes, I discuss Checkpoint in 2 methods. One method will be for your understanding. One method will be for like so that you can remember the packet flow in the better way. So 2 packet flow I'll be discussing. So the so see, let me show you. This is the packet flow which you should remember always before going to interview, because interviewer will ask to you what is the packet flow of Checkpoint. Although I'll discuss this in very detail in some time, but these 10 steps you need to be remember always. Okay. Apart from this, one more packet flow is also there, which I used to discuss for your understanding so that you can understand what sort of packet processing happens inside the box. For an example, if I go on Google here, if I go to images, this packet flow. So this is the image right now. So, this one. So this is how the packet will be flowing inside your box. These all are the steps where the checks will be happening inside your firewall. Okay. So this is how we'll be proceeding further. So, and apart from this, if you have any of the interview which is coming in your future, you can ask our team to take a mock interview of yours, and our team will schedule one mock interview with you, and you can check your knowledge whether you are prepared for that original interview or not. And believe me, guys, this technique works a lot because you will be giving two interviews for each and every interview you are going to give with the company, right? So this is the things you will be getting in this particular course regarding the lab. I'll be telling you how you can build your lab on Google Cloud. Apart from that, if you want my help, I can help you to build your own lab in your laptop. All right. Now, apart from this, let me mention here the lab creation also, right? So these are all the things you'll be getting in this particular course. Now, my name is Vikas, and I'm working with a network security engineer in last 8 years. And apart from that, I have 5+ years of relevant experience in teaching. So now I'm going to bundle all of my experience and I'll be sharing with all of you guys so that you can perform well in your organization, you can troubleshoot well, you can understand the concepts well. Okay. This will be the topology. We have discussed this thing in our last class also. This will be our topology in our classes, which will be discussing. This will be our central, or you can say this will be our DC setup, and this will be our LAN, this will be our DMZ, and this will be our WAN, where I'll be having the ISPs which will be connecting the routers, and from here you'll be getting the traffic on the firewall. This is how we'll perform our lab. So as I have mentioned earlier, also like 80 to 90% labs will be covered in this particular topology. But if there will be something else, we'll build a new topology for that. Not a problem. Okay. And you can see I have used two firewalls over here, and they both will be working in the cluster. Now nodes things I have already covered, and smart also I have covered. Let me just brief you once again. So this SMART stands for Security Management Architecture. So S stands for Security, M stands for Management, ART stands for Architecture. So this is the full form of this. In this smart security management architecture, or you can say smart architecture, you'll be having three components. First one is called Smart Console. Second one is called Management Server, and the third one is called Security Gateway. Okay. So like if you talk about in the diagram, you have all the three components in front of you. The first one, this computer type of diagram, you can say this is in this computer, you'll be having your smart console. On this server, you will be having your management server, and this server is nothing. It's just a Gaia configured in a different manner. Okay. And these all are your gateways which are available over here. So in checkpoint architecture, you cannot manage the GUI. One moment, guys. Yeah, you cannot manage the GUI of the firewall from the firewall. You have to manage that GUI from the management server. Okay, you have to create the policies and everything on this management server. After creating it, after verifying it, you can push those policies, those settings and everything to the security gateways. And how you can configure those policies, how you can manage those policies. To manage those, you need to use the Smart Console application, which will be there on this particular computer. All right. So this is how you will be managing this particular setup. So this is your, you can call it three-tier architecture, you can call it smart architecture or whatever. There are multiple terms, interviewer will ask to you, but you have to remember that this is the one architecture which is there in Checkpoint, okay? And in the industry, you will see that multiple companies are there in the market who have copied this particular architecture, okay, because this is not patented. There are certain technologies which are being patented by Checkpoint. For an example, stateful inspection. Stateful inspection is developed by Checkpoint and patented by Checkpoint. So all the firewalls which are there in the market who are using the stateful inspection, they are paying a royalty to Checkpoint because that's a patented technology. Or maybe they have bought that technology from Checkpoint. But this architecture was not a patented one, so multiple companies in nowadays they are using this particular architecture. Okay, so this is some basic uh, topics. I would say packet filtering, stateful inspection, app awareness. This is basically traffic control methods. This is not related to Checkpoint only. This is overall scenario in your firewall field, or you can say section. These all three methods are there which will be used to handle the traffic, to filter the packet. The first one is called packet filtering, the second one is called stateful inspection, and third one is called application awareness. So in the packet filtering, it's the behavior of each and every fire, this is the behavior of traditional firewall. For an example, if you talk about the ASA, Cisco ASA, it used to filter all the packets which used to come on the firewall, whether it's coming from the inside, whether it's coming from outside, all the packet used to be handled by the firewall. Second one is stateful inspection. So as I have mentioned just now, that stateful inspection is developed by your Checkpoint. And in Checkpoint, you have this feature where what happens is whenever a new packet leaves the firewall, one table is maintained on the firewall level, and on the basis of that table, your return traffic will be evaluated or will be passed. So let me go to our notepad. Okay, let me have a new section. Okay, let me have a new section. So let's suppose this is your firewall, and let's suppose this is ASA, okay? This is your one client, and this is your one server. So what happens is, let's suppose this client want to access this server. So generally three-way handshake will happen, right? This is the start of the network. Before this three-way handshake, your DNS will come into the picture and resolutions will be happening, cache will be checked. But let's assume that three-way handshake will happen. So this client will send one SYN packet, right? Now this SYN packet will come to the firewall. Now the firewall will evaluate this packet on the firewall. It will check all the things like policy, like NAT, routing, and everything will be checked for this packet. And if everything will be good, this packet will be passed to server. Now, in three-way handshake, second packet comes from the server side, and that is called what? SYNAC, right? So this SYNAC will again come into the picture on the firewall, and firewall will again intercept this packet. It will decrypt this packet, or if it's not encrypted, so it will evaluate that packet, and all these things will be checked again. So whatever packet is going from here to server, or it's coming from server to here, it will be evaluating each and every packet on the firewall. That is called packet filtering. Okay, but if we talk about stateful inspection, so what happens is this is a client, this is your server, same thing will be happening, right? From here, you'll be getting one SYN request, and this SYN request will be coming to firewall. Firewall will be evaluating this SYN packet. When this packet will be leaving from this outside interface, before leaving, because firewall will understand like now I have to pass this traffic basically, right? So before leaving, before passing to the outside interface, it maintains one connection table. Now you can call it connection table. One moment. Yeah. You can call it connection table. You can call it state table, whatever you want. So in this table, this firewall will maintain what was the source IP, what was the destination IP, what was the protocol, what was the direction of the traffic, and what was the source port, what was the destination port. So these information will be maintained in this particular table, and this traffic will be passed. Now, what is the relevance of these information is getting maintained in this particular table? The relevance is after the SYN request, when SYN will be received at the server end, the server will send back the SYNAC. Now, when this SYNAC will come to the firewall, so this is the second packet for the same source and destination, correct? So this time your firewall will not check the policy. Policy lookup will not be happening. And believe me, in your organization, in one enterprise, the minimum policy base, or you can say average policy base, is of 2000 policies. So you can now understand, if you are bypassing evaluation of the policies, how much policies evaluation you are bypassing. So somehow with this particular state table, you are saving lot of effort, lot of time of the packet processing. So your packet which is coming back to the firewall for the source, same source destination protocol and source port destination port, it will not be for that the policy will not be evaluated, and that like communication will be passed on the basis of the entry you will be having in the state table. So that's the benefit you will be getting in the stateful inspection. Now in checkpoint, you have one more technology called secure accel, security acceleration. Now By default, this will be enabled. By default, security acceleration will be enabled in checkpoint. What happens before checking the state table or connection table in checkpoint? Firewall will check the secure accel table. So this table, this secure accel table will be checked before the connection table, and if the entry will be found inside the secure table, all the process, all the slow path of the packet processing will be bypassed and the traffic will be landed to the application checks. Now, if you want to verify this, let me show you the packet flow, the bigger packet flow of checkpoint. Here it is. Hope you guys can see my screen, right? Now let me make it zoom. Can you see this section? Huh? This is the you can say secure accel, checks will be performed at this particular section. And can you see, let me zoom it more. Can you see secure accel connection table? The second step. If the answer will be yes, the traffic will be coming to this particular step and it will be coming to the fast path. This is the fast path. Now what happens at the fast path? Your all content inspection and everything will be checked if required. Otherwise, can you see this arrow? The traffic is getting passed and it's getting landed to your NAT and everything. Now from here, it will be passed directly to your capital O, right? So that's the benefit of secure accel in your checkpoint firewall. And if you talk about the connection table, here the connection table it is. Now, if the entry of that connection will not be there in the security acceleration, in that case, the answer will be no, and this is how the traffic will be landed to slow path, and here your connection table will be built. Okay, and after the connection table, if the connection match will be found, then you can say the policy lookup will be bypassed and the connection will be coming back to this particular destination NAT option. But if security acceleration table will be matched, the traffic is bypassing all the packets, all the checks, and it's directly landed to your outside interface. So that's the benefit of security acceleration. All right. Now, the third thing was in that particular packet filtering method. Do you have any doubt in this stateful inspection or maybe the security acceleration? Although it's a brief for now, but if you have any doubt, you can ask me right now.
So the Excel table build after the session table built, or it built on initial connection itself?
Uh, see, the first packet which will be coming to the firewall. Let me just integrate this packet flow in the here, and then we'll discuss. It's visible to everyone, right?
Yeah.
Okay. So see, when the first packet will be coming to your firewall, then that packet will be taking this path. It will be coming
Okay.
to slow path, and then all the lookups will be happening, and then if the content inspection required, then it will be sent to this content inspection. Otherwise it will be going to the routing and then the outside interface. This is how your first packet will be processed, guys. But after the first packet, certain things will be created. For an example, your policy match will be happening. That's the reason packet has gone to the downstrips, right? Otherwise, it would have discarded over here, right, at the policy lookup. But that policy was there, so that's why the packet was passed. Now, when the packet was passed, your connection table entry was created over here. Simultaneously, your secure Excel table was created for the first packet. Always remember. Now, when the return traffic will be coming back, your secure Excel table will be entry will be matched over here, and this traffic will follow this particular path, the second packet.
Okay.
Okay. So if the content inspection required, it will be checked. Otherwise, it will be passing from here. Can you see this line?
Yeah.
This is how it will go. That's the path it will choose for the second packet, and that's the path it will choose for the first packet, right? So that's the feature,
Okay.
that's the additional. If you talk about other firewalls, they have the connection table, and their packets are matching the connection table. They do not have this secure access feature in their firewall, because this is also a security acceleration feature patented by Checkpoint, developed by Checkpoint, and the patented by Checkpoint. All right. Now, third thing was application awareness. Now, if we talk about the next generation firewall, whatever, like I'm not talking about any vendor specific firewall, any firewall means if you talk about Palo Alto, right? If you talk about Checkpoint, if you talk about ForcePoint, right? If you talk about FTD, Cisco Firepower Threat Defense. If you talk about any of the firewall, there are multiple vendors in the market. If they claim that they are next generation firewalls, then they have the feature called application awareness. Now, what do you mean by application awareness? Do you know a company named Facebook? Facebook is a bigger umbrella, right? Facebook is the bigger umbrella below which you have multiple applications. Facebook chat, right? Facebook
So,
game.
because sorry to interrupt you, I have a question related to secure Excel.
Mhm.
So the thing is, I mean, when the when the packet hit the firewall, it first create the session. Okay, it goes through the policies and all,
Mhm.
right?
Mhm.
And then it will move on to the. I mean, the first packet will be going through all the
Slow path. It will be
all
going to
the
slow
all
path.
the checks, right?
Yeah.
From the second packet onwards, it will bypass what all steps, right? How what all lookups will get bypassed, and it will directly hit the other points.
See, if that will be detailed discussion of the packet flow, but let me just give you a brief of it, okay? So you understood, right? When the first packet will come, your slow path will be come into the picture, and it will follow this path, right?
Correct.
Now, when this particular connection table was created, this secure Excel table was also created. Now, when the
Yeah.
second packet will come into the picture, your secure Excel table will be matched. Your secure Excel connection table will be here is the table, right? It will be matched over here. Can you see this? Yes. If the match will be found, these below steps will be bypassed. The traffic will go here. Here it will be checked whether it's a reset packet, it's a SYN packet, it's a FIN packet, which type of packet it is. Do you remember TCP flags? Do you know or not?
Yeah, correct.
Right?
Correct. Correct.
So if there is some, like in the packet, if any of the TCP flag is there, right? So that thing will be checked over here. And if this particular thing will be matched, so if we talk about TCP FIN request, right? FIN, reset, SYN, acknowledge, push, and what was the sixth one? Urge pointed. These are the 6 pointers, 6 flags, right? If any of the flag, any of the like value of any of the flag is 1, so in that case, this condition will be matched. It will be yes. And for these particular packets, none of the content inspection will come into the picture. It will be bypassed by default. Because in these packets, you'll not be having any user data, right? No data will be
Yeah.
there. So that's the reason content inspection will not come into the picture. But if this condition will not match, this condition will be saying no, then in that case the packet will be coming here and the decision will be made whether the content inspection required or not. If yes, then fast access rule will come into the picture. Now what is the fast access rule will come into the we'll discuss this thing in our detailed packet flow, but right now just understand the fast access rule is the rule which will be created by secure acceleration, secure accel thing. Okay, so if this particular thing will be checked, if this fast accel rule will be found, then this again fast path will come into the picture. If no rule will be there, no fast accel rule will be there, then your medium path will be chosen. This
So that rule will be created in access policy itself?
no, it will be created by default.
Okay, that will be right.
Okay, so
Okay.
if like to be very sure, if entry is available in secure Excel table, your slow path will be bypassed 100%. This particular section will be bypassed. Now it depends upon the traffic. It depends upon the multiple parameters. If give me just one moment. Hmm. Yeah. So now there are multiple factors, multiple things involved. If these parameters will be matched, which is available in this particular section, then it will the decision will be made whether the packet will take this medium path or the fast path. All right.
Okay.
I hope the doubts are clear now. All right. Do not
So
worry. Like
all the session, I mean, all the connections there in the session table will have this secure connection table as well, right? Secure Excel.
if secure Excel is enabled.
Okay, so it required to enable, right?
Yeah.
It is not by default enabled. Okay.
By default it's enabled, but some of the organization disable it because it's adding one more security step in your first packet, right?
So will that impact the overall performance, the firewall performance?
Generally, like it increases the firewall performance, but there are multiple scenarios, multiple organization type, multiple architecture where it gets slow. It made the firewall slower, right? If let's
Okay.
suppose you are using checkpoint 800 series and
Mm-hmm.
you have enabled secure Excel, definitely this firewall is under capacity, right? So such features will make this firewall down. So make sure like these features, generally these features will be enabled for your DC's firewall so that, your traffic analyzing will be done in a very efficient way. Although like
Yeah.
if feature is available in all the checkpoint boxes, you can enable it any of the firewall you want. All right. So we were discussing this application awareness thing, and we were discussing about the Facebook. Like we were discussing what is application awareness and what is it basically. So I was telling you that if we talk about the next generation firewall, all the firewalls having this feature basically, application awareness feature. What is this feature? Let's suppose the Facebook. Facebook is the company who is having the bigger umbrella, and under this Facebook, you have multiple subdivisions, right? For an example, Facebook chat. Inside the Facebook application, you have Facebook chat, a totally different application. You have Facebook games, totally a different application. You have Facebook feeds, right? You have Facebook calls, right? You have Facebook, what was that? Let's talk about these four because I'm not able to recall all the names. Approximately 15 to 20 subdivisions are there for the Facebook. 15 to 20 categories are there basically. When we talk about the content, sorry, URL filtering, right? You will see there, you'll get list of the applications for the Facebook, right? So now let's suppose for your normal users, right? Your normal users, this whole Facebook should be blocked, right? Inside your organization, no one in your team or inside your organization will be able to access the Facebook. But nowadays, digital marketing, digital marketing is the key for all the organizations, right? Now, where they will be doing the digital marketing? On the Facebook, on the Instagram, on the TikTok, right? These all are the social media platforms where they will be doing the digital marketing. So from the Facebook chat will not be required by default. Definitely, any of the person who is doing the marketing for them, Facebook chat is not required. But Facebook feed is required, right? On the feed, they will be doing this particular marketing, right? Calls will not be required, games will not be required, chat will not be required, but Facebook feed will be required. So how you will be blocking the Facebook for all the users and how you will be allowing Facebook feed for only and only for marketing persons. You can do it if your firewall is application aware because there you can mention that Facebook feed for this particular source called marketing is allowed. This is how you can categorize your policies for application awareness. So if your firewall is application aware, you can create the rule on the basis of application. You can block the rule through the application and so on, right? So if I talk about, have you heard of the company name Boat? It's a like earphone manufacturer, like music company, basically musical devices they create, right? Earphones and everything which is coming nowadays, right? So if we talk about this company, the sales team of this company does the sales on Amazon, right? On Flipkart, right? So for their sales company, sales team, these URLs should be, these applications should be allowed. But rest of the users, for an example, the HR team, this particular Amazon or Facebook may not be required, right? So you can block these applications for HR team. You can allow these applications for your sales team. So this is how you can play if your firewall is application aware. Okay. Now the checkpoint packet flow, which we'll discuss later on. Let's come on the installation of the Gaia. So see guys, this particular tab, this particular uh, PPT slide is very important. If okay, okay, this slide is very important if you are interested to go in any of the project team. For an example, there are multiple companies who have their separate project team, who have their separate operations team, right? So if you are interested to go in a project team, this particular slide is very important. Why? Because here you will understand what are all are the methods to install the Gaia. Now there are basically two methods to install the Gaia. The first one is called distributed and the second one is called standalone. Both are the same methods, both are follow the same approach, three-tier architecture, but the approach is different. Let me tell you how. The first deployment is called distributed, right? Now, in distributed deployment, you will be following the same three-tier architecture and you will be having separate devices, one for the client, one server for the SMS, like security management server will be there in the middle, and then the third component will be your gateway, right? The first and the second and the third component. So this is three-tier architecture, three components are there. This client will be accessing the server and it will be managing the gateway from the server. This is three-tier architecture. This is called distributed deployment, where you will be following three-tier architecture with three separate components. All right. Now, the second method called, the second deployment method called standalone. What is standalone? Standalone says if you have a lower budget, if you have not the feasibility, if the site is not that much big, what you can do, you can club these two devices. You can make them one. So logically, there will be physically, there will be two devices. Here, physically, we have three devices, right? In this particular distributed environment deployment, we have physical three devices, but in standalone, physically, there will be two devices only. The first one is called your client, where a smart console will be installed, and the second thing will be your firewall. Now, in standalone, what you do basically, you divide this appliance into two parts. The above part will become the SMS server, the below part will be gateway. So from this console, this client, you will take the access of this particular SMS server, and from this SMS server, you'll be managing this gateway. Although they are on the same appliance, but they will be acting as the different appliances. So physically, there will be only two devices, but virtually they will still be following the three-tier architecture. I have seen people who are confused that if I will be deploying our firewall in standalone. In that case, firewall will not follow the three-tier architecture. This particular understanding is totally wrong. Firewall deployment will follow three-tier architecture in any of the cases because the base of its architecture is the three-tier. If you'll not follow this, you won't be able to manage your firewall. So now the problem with the standalone is you will be having a single point of failure. If some problem will be occurring in the SMS server, by default your gateway will be down. If any of the problem will occur in the gateway, your SMS will be down. So that is the reason we never prefer, never recommend this standalone deployment. Instead of this deployment, what we do, we say that build your SMS server in your DC location. Let's suppose I have my DC in Mumbai, okay? And I have the gateways in Chennai, I have the gateway in Bangalore, I have the gateway in Delhi, okay? These all are my gateways, and let's suppose these are the small gateways. And in the DC, I have one bigger firewall also. This is my data center firewall. So what we generally say that in your data center, you have this three-tier architecture, right? From you have this client, from the client you are managing the server, and from the server you are managing the gateway, right? So what we say that you can manage these gateways from this server. All these gateways will be managed by this server. So instead of standalone deployment at the locations, build a bigger management server in the DC and manage all the gateways with the same SMS server. And this particular deployment will do in our lab, and we'll discuss how you can achieve in your particular lab scenario. So that's the reason we'll never prefer or never recommend this particular deployment method. Okay. All right. So that's all for today. Thank you very much you all to joining in this particular lecture. We'll meet you in the next lecture. Till the time, happy learning.